Hey, what's going on, guys? I don't know what you think of the new setup. Let me know. Shoot me a comment. Let me know. But yeah, we got some trees in the background. Oh yeah, there's a boat. See, that's my boat right there. And those are my friends. They're all just chilling. You just ignore them. It's fine. The water is really still today. It's like not moving at all. Clouds haven't moved in the last like 4 hours. So I don't know. It's like time standing still. So anyway, but yeah. So change the setup a little bit. I don't know. Let me know what you think. So I just want to make a quick video of the Xgecu T76. So like all my things, pretty much everything I own, I like to tear apart. I was going to do a two-part video where we took a NAND flash and reprogrammed it with the Xgecu, but all of the other NAND flashes that I took off from various devices, I don't have the adapters for, and the one that I have doesn't work with. So that was stupid of me, but whatever. I guess it was worth a shot. At least I got some footage of something. But yeah, so this is for anybody that's not familiar. The Xgecu is a programmer. It's like a reader, writer. You can program various chips with it. It comes with these little adapters here. So the programmer itself is about 150 bucks. The adapters are about 40 or 50, depending on what kind of adapter they are. And yeah, so basically they just plug in using all these pins here, this little pin header, and then these are all like ground pins, and basically to prevent you from putting other things in the socket. It's like, and so you don't put this in the wrong way around. So anyway, but yeah, it's a pretty nice tool. It uses well, you can't really see it, it's out of focus, but it's USB-C. It's got this little lever arm here to open and close the ZIF socket. So ZIF stands for zero insertion force. It's got a couple LEDs on the front, power and run, and then it shows a little diagram here, which is pin 1. So it says IC, and then it's got that little dot in the corner. So if you ever put an IC in here, that's pin 1 up in that corner. I'm not sure I don't know what that means. If you put 2 in together, I don't know if you can put 2 at the same time. And then it's got another, well, it's out of focus. I'm using a different lens, but it's got another pin header up here. And sometimes certain adapters, depending on what chip it is. So for example, like this NAND flash chip right here has a whole lot of pads on it. So if it's a chip with like a bunch of connections and there aren't enough tabs in this ZIF socket to accommodate the chip, then what'll happen is they'll take this adapter and there'll be a ribbon cable that comes across and plugs into the socket. So it'll be plugged in with the ribbon cable and plugged into the ZIF socket. So yeah, and then the software is pretty straightforward. You'll see it a little bit later on down the road, but yeah, so it's I don't know what the 5 gigahertz. So yeah, it's USB 3.0 super speed, and it just like 5 gigabytes per second or whatever. I don't know why they wrote 5 gigahertz, but yeah, so that's a pretty fast reader. But yeah, this is their like top of the line model. And this is, I mean, there's a few other options I found. I found a couple like not really homemade, but a couple options that seemed like they were kind of like almost DIY, just some smart person like built their own programmers. And one of them was like 50 bucks. I don't remember the name of it, but the adapters were like, they wanted like $150 per adapter, but the programmer itself was only 50 bucks. And then this one's the opposite. This one's the programmer's 150 bucks and the adapters are like 40 or 50 bucks. Yeah, so it has 4 Phillips head screws on the bottom. Just make sure they're all unscrewed. The plastic clamshell design, it feels pretty good. It feels like decent plastic. Doesn't feel like it's made cheaply. the embossing or whatever, like the stamp or press or whatever it is that they use, the tooling for the plastic, looks pretty decent. It looks like they use pretty sharp tooling. Like it doesn't look cheap, I should say. So it looks pretty decent. And they got a couple security stickers. So there's one on that side, and then there's another security sticker on this side here. So we're just gonna do the right thing and cut through them. Because why not? I'm not gonna return this thing. I could care less. Alright, so bottom half comes off. Here is our PCB. You can see all of the various traces. There's a whole bunch, and then we got a couple ICs on the bottom there. Looks like we have some kind of ROM chip or something. There's another chip up there, some small little package. We have a crystal oscillator, some transistors by the power section, power supply. Got some bulk capacitors right there, and a bunch of transistors here. So these are probably used as gates to turn on and off certain voltages going to like different chips and whatnot. Because the way this works, you know, you can put a bunch of different chips in there. So you tell the software which chip you're programming, and it'll switch on and off these different gates to like the power supply. So that way the correct voltage gets to the correct pin. And I'm not sure what these two chips are. They may be like level shifters. So you can also program at various voltages. So you can program at like 1.8 volts, 2.5, 3.3, I think 3.0. I don't know. But let's take a look at it under the microscope real quick, and then we'll flip it around and see what's on the other side. All right, so let's just zoom in a little bit. Oh, no, there's a capacitor coming off. How did that happen? Okay, that was not me. I literally babied this thing when I took it apart. There's no way I did that. I'm gonna look back through my footage because you can see it. It's like barely soldered on. And the trace is like ripped up. What the hell, man? Alright, we need to fix that. That is no bueno at all. Alright, let's fuck. Alright, I'm gonna have to turn my heat gun back on, and I'm gonna have to heat that capacitor up and get it to attach, because that's not supposed to be like that, and I'm pretty positive that I did not do that. So give me 1 second, I'll be right back. Okay, let's see what we can do, because I think I'm pretty sure it ripped the pad off, but I mean, we can always give it a shot and see what happens here. But I'm like, I don't know, I'm like 90% positive I did not do that. Flip it over this way real quick. Did it reflow? Okay, well, it's on there, so it's crooked, but I don't care. I'm not gonna mess with it any more than I have to. Man, that is ridiculous. Literally just bought this thing. You better believe I'm gonna look look back through the footage and see. So that might explain why, I don't know. Because like it read that one firmware fine and it copied it just fine. But then we started getting that one, there's like one error that we started getting. Like some of these don't look like they have, oh no, I guess yeah, it's got enough solder. For a second it looked like maybe there wasn't enough solder on the some of these components here. All right, let's get this little hair out of here. All right, air off, heat gun off. Yeah, you can see, I mean, it's ugly, but whatever, it works. So at least it didn't rip the pad off. You can see it's soldered on that side pretty good. And it's not the best, but it is soldered on that side as well. So I'm not going to touch it. I'm just going to leave it. That's fine. As long as I know it's making a connection, I am okay. If this was like work that I was doing for someone else, then I would have taken it off completely, pushed the copper trace down to the board like flush, and then I would put the component back on top. So I think we're good to go. Got a couple blank components there. I wonder, I don't know. All right, so let's see, what do we got here? Let's see what some of these ICs are. So we got an LM258. You guys can look these up if you want. We have a SM16306SU. No, SJ. Okay, yeah. So SM16306SJ. So we have two of those. Yep, we have two of those. And then we have that one. Where is it at? Where are you at? Nope, 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 nope. Yeah, that one right there, the LM258. And then let's see what this little one is on the other side here. So this other one here is a MS, what is it, 1104? Yeah, MS1104. So, cool. Anything else to note? Nope, not too much. So let's go back under the table camera real quick, and let's see if we can't get this out. Okay, so we're gonna pull that up. Oh man, that is stacked. All right, so there's a lot of stuff on here. It's a dual PCB design. You can see there's a bunch of inductors or chokes underneath. There's a big fatty right there. Looks like we have a couple board-to-board interconnects, and it looks like the two boards are soldered together, so I'm not gonna go that far. I don't know, maybe in a later video. Let me see if there's anything under there. Oh yeah, maybe I will. I don't know. There's a big board underneath there. It's like an Atmel or something. It's a pretty big chip that's right underneath that capacitor that was damaged. But yeah, so let's take a look at the top, and you guys can see a whole heckload of transistors. So let's, yeah, this is what makes it no, I wouldn't say so expensive, because it's not expensive for what it does. I mean, it's a very, very fair price tool. So we got another chip here, SM74HC595D. Got a little capacitor next to it. We have a whole huge bank of switching transistors going down the side. Then we have another chip here. This is another one of those SM16306 SJ. And then we got another SM74HC595D. Got a, if you guys ever wondered what these are, this little package right here, this is a quad bridge resistor. So basically it's 4 resistors in one, and the value is printed on the top. It just makes it easier than putting 4 resistors, like, you know, in parallel next to each other. It's just easier to install a single one of those packages. It's common for like data lines or whatever, like if it's a pull up or pull down. Yeah, that's another one of this SM blobbity blobbity. And then we have a whole bunch more transistors on this side. And see anything else of note? Nope. So a lot of the same components. These are definitely like level shifters, switching transistors to switch the different voltages and stuff. I mean, there's going to be a whole whack load of them on the board. And I'm just seeing if there's anything else of note. No. And then let's take a look at the power board on the bottom, so you can just barely make out part of it. So VIO, which is voltage in out. We have some solid capacitors. We have some of these inductors. So 2R2, 3R3, 6R8, and big old chunky boy right here. You can see that's flexing on the board. So this thing must have taken a tumble in shipping. Because that's coming off the board too. Man, I'm gonna need to glue that down. This is horrible. Yeah, the whole trace is like ripped off the board. Here, I'll show you guys. See that 150 right there? You can see down next to that diode or whatever it is. See that trace? How it's all like bent up funky? I am really surprised that this thing is still working. Yeah, that inductor is like super loose. Loose at the other side too. Yeah, I'm gonna have to glue that down because that is no bueno. Like, that is not good at all. I'm not happy with that. And like, you know, you saw how it was packaged. It was packaged decent, but man, this thing must have really got kicked around or something, or they just like throw these around at the factory a little bit. So everything else is good. Yeah, that's good. That's good. All right, and then lastly, before we sign off, I'll show you down in between the 2 PCBs here, and you can see that big old chip under there. Yeah, there you go. See all those balls? So that's just like one big giant package underneath the board, and you can see there's a whole bunch more surface mount devices. And just a whole bunch more transistors, just one after another, after another, after another, just all next to each other. So pretty cool. And let's go back to the table real quick. So anyway, yeah, so you guys can see that's the inductor that's about to fall off. But yeah, the construction itself is good. There's no reason for them to have to glue down these inductors. The only thing that I would say would be an oversight is whoever routed this PCB, like did the design, they didn't put ample enough conductor, like traces, you know, underneath for this to stay down. They made them just a little too thin. In that case, if the conductors are thin or the traces are thin, that leads to a component of this mass right here. You really want to at least add some sort of whatever you call it, some sort of glue or compound or whatever, Celastic, to hold it in place so it doesn't, you know, go flying off in shipping. Obviously something might have happened at the factory because that one component knocked off on the back there. But this right here, I don't know, that seems something else. That seems like it was done in shipping or something. So but anyway, guys, yeah, so that is the Xgecu T76. After this video, I'm going to give it a plug in real quick, just take a look and see, make sure that it's functioning correctly. But I need to glue that down first. So anyway, hope you guys enjoyed the video, and I will catch you next time. Peace.